While the International Space Station continues to fly on with its mission, NASA is also moving ahead with some testing on its next human spacecraft, that is, the Orion vehicle. After a successful flight test of an uncrewed spacecraft late last year, the program is planning another important parachute test next week. This one will include some planned failures of a couple of parachutes in the system. And this morning we're going to learn more about that plan. I'm joined by Chris Johnson, who is the Orion Capsule Parachute Assembly System Project Manager. Good morning. Welcome. Thanks for taking the time with us this morning.
Yeah, thanks for having me.
What is it that you will be testing in these tests in Arizona next week?
Yeah, so we'll be doing an airdrop test that tests the full-scale Orion parachute system, which includes forward recover parachutes, drogue parachutes, pilot parachutes, and main parachutes. And we use a representative full-scale Orion capsule to perform the test. It has a critical interface to the parachute system, as well as it generates a representative wake to be a more accurate environment to the parachutes. So to do this test, actually to get to the test point, that's half the battle when we go out and do our test in Yuma. So we use a test technique that we've developed. We use a C-17 to take the test vehicle, which includes the PTV, up to an altitude of either 25,000 feet or 35,000 feet, and depending on the test objectives. We extract that vehicle from the C-17. We separate the PTV from the platform or cradle that carries it up there, and then we deploy programmer parachutes behind the PTV, and that's used to get the Orion parachute system to its test point. So it's a very complicated test technique. We use up to 9 other parachutes other than the Orion parachute system to perform an airdrop test, and that is one of the big engineering challenges we have when we do an airdrop test.
And we were just showing folks one of the recent tests there. How is what you're going to be doing this time different than what you've done so far?
So this coming week we're doing what we call a minimum system test. Our system is designed so that one of the two drogue parachutes can fail, and one of the 3 main parachutes can fail and still safely land the vehicle. So what we're doing this coming week is testing those failures, one drogue out and one main out, in a sequence, which is kind of an extreme condition for flight. It also is good in terms of we're trying to understand more of the vehicle stability under those conditions underneath the parachutes, and so obtaining the data on that will help engineers evaluate and predict the performance of the vehicle and the parachutes as a larger integrated system.
You're taking the opportunity to find out how it's really worked, not just what we thought on the design board.
Yes, exactly. We use these tests to go to the extremes and put the parachutes, through a lot of work in the extreme envelopes of the design to ensure that we have a safe system for the vehicle.
This sounds like a dumb question. They say there are no dumb questions, but why are parachutes for this vehicle so important?
Well, obviously, the parachutes are very critical in the final phase of the descent and landing, a safe landing of a vehicle. So, the vehicle after re-entry, it's going through the atmosphere. Once it gets into the thicker part of the atmosphere, the RCS thrusters become less effective, as well as we need to slow the vehicle down for a landing. So we deploy the drogue parachutes around 310 miles per hour, and that helps also stabilize the vehicle. It slows the vehicle down to around 130 miles an hour, and that's when we then deploy the main parachutes by using the pilot parachutes. And so the main parachutes then slow the vehicle down to their final splashdown velocity of 17 miles an hour, and that is a safe landing in the ocean.
Is there any steering involved, or is it just braking?
It's mostly braking. Now that said, we do use roll control underneath the parachute, so the RCS thrusters still are used to orient the vehicle on the final landing if there are winds such that we're moving in a horizontal velocity. So we're trying to keep the toe of the vehicle pointing forward and landing in the ocean first.
Now I understand there's still one more test after this one we've been discussing in the engineering evaluation series. And then you move on to what's called qualifying the whole system for flight. So what does that testing series look like?
Yeah, so our qualification testing is a series of 8 full system, full scale tests that really put the final design, which we're going to define in less than a month at our critical design review. It'll put those parachutes through the extreme conditions and environments that we want to expose them to ensure that we have a safe system for final human certification for Orion.
Mentioned that there was a successful flight test last year. What did you learn about the parachutes at the end of that test back in December?
Yeah, so now while we do for our airdrop testing, we're able to heavily instrument and place cameras on the test vehicle that give us a lot of valuable engineering data, and is the bulk of what we use to predict the performance of the parachute system. But when you have a reentry of a spacecraft, you can learn some additional things that are just hard to represent, even doing airdrop testing. An example is one of the things we learned is that the capsule wake, or the wake that's generated behind the capsule, is a little bit different than what we can test to. And so we learned a little bit more insight about the drag performance of our drogue parachutes. So we use that to tweak the models. But in general, the EF-21 flight that we had back in December was a very nominal flight and very consistent to the performance that we see when we do an airdrop test in Yuma, Arizona.
Which is, I take it, a good thing if it's actually behaving the way you expected it to.
Yes, that's what we like to see. We like to learn about the vehicle, about the parachute system, and what to change when we're doing these airdrop tests, which is the whole purpose of them, so that when we have an actual spacecraft flight, we have a safe system.
Be eager to see what happens next week in Arizona, Chris. Thanks very much.
You're welcome.
Chris Johnson is the Orion Capsule Parachute Assembly System Project Manager.